The Cafferty Group, technical service advisors with offices located in Nebraska, Iowa, Kansas, and Colorado, presents Essential HVAC Principles, Refrigerant Metering Devices. Depending on the HVAC system type and effective efficiency, will require the use of different types of refrigerant metering devices, such as thermostatic expansion valves, metering pistons, capillary tubes, or electronic expansion valves. Let's start off with fixed orifice systems. Fixed orifices can either be a piston type or utilize a distributor. The distributor feeds capillary tubes, which terminate in the evaporator coil. The piston comes in various sizes and is interchangeable with the capacity or tonnage of the condensing unit. Always follow the manufacturer's instructions for piston sizing if using the fixed orifice for HVAC refrigeration. Capillary tubes are considered a fixed orifice since the hole in the tube or tubes are a fixed size. Capacity is a function of length, inside diameter, and pressure differential across the tube. It reduces pressure along its length. Excess head pressure equals excess flow. Reduced head pressure equals reduced flow. Good light commercial control. Correct refrigerant charge is critical. Liquid orifices. Here's an example of a liquid orifice for a large tonnage chiller. Modulating metering device. The TEV meters refrigerant to match the evaporator load by responding to both evaporator pressure and suction line temperature to maintain superheat. This image shows the components making up a thermostatic expansion valve, or TEV, and how it works. The sensing bulb is connected to the power element with a capillary tube. The sensing bulb and capillary tube are charged with the same refrigerant contained in the system you're using it on. The sensing bulb is attached to the suction line of the evaporator and wrapped with insulation. As the suction line temperature increases, the pressure in the sensing bulb increases and pushes on the diaphragm in the power element to move the metering pin and allow refrigerant to flow into the system. When the temperature in the suction line decreases, the pressure in the sensing bulb decreases, and it releases the pressure on the diaphragm to close off the metering pin, reducing the flow of refrigerant through the coil. You'll also see the valve packing to seal the metering pin. You'll see the valve inlet, internal check device to prevent backflow that is optional, superheat spring, superheat adjusting stem, also an option, the pin carrier, the valve outlet, and an external equalizer. How a thermostatic expansion valve, or TEV, works. There are three different forces at work in a TEV: bulb pressure, spring pressure, and evaporator pressure. Bulb pressure. The bulb is charged with the same refrigerant as the system and is in a saturated condition. It is mounted on the suction line. As its temperature changes, the pressure changes. The pressure is an opening force within the power element of the valve. Spring pressure is constant and pushes against the diaphragm as a closing force, counter to the bulb pressure. The spring pressure is calibrated when the valve is set by the equipment manufacturer or the installer. Evaporator pressure increases or decreases the closing force as the load varies. Based on the balance difference between these three pressures, the valve will either open more or close more. Here are the three pressures. The sensing bulb has an opening pressure. The evaporator has a closing pressure. The spring has a closing pressure. So the bulb pressure, P1, is equal to the evaporator pressure, P2, plus the spring force, P3. Here is an adjustable and a non-adjustable TEV. Please be aware that if the power element on either valve or the bottom cap on a non-adjustable valve are loosened or removed, the valve will leak refrigerant. Thermostatic expansion valve. The TEV responds to evaporator superheat and modulates the refrigerant flow to match the load. The TEV controls the quantity of liquid refrigerant entering the evaporator. It ensures that the refrigerant will be completely vaporized within the evaporator and maintains the proper amount of superheat in the system. A valve with the internal equalizer. It applies closing force pressure from inside the valve on the downstream side of the needle valve, which is evaporator pressure. On an evaporator coil with a 0 psi pressure drop, you can see on the diagram on the right that the evaporator inlet pressure is 27 psi and the outlet pressure is 27 psi. So we have a 0 psi pressure drop. So the closing pressure equals the 27 psi plus 7 psi spring pressure equals 34 psi, evaporator inlet pressure and spring pressure. The bulb pressure necessary to open the valve is 34 psi. So if we use a PT chart, the bulb temperature equivalent to 34 psi is 37 degrees. The saturated temperature equivalent to the evaporator outlet pressure is 28 degrees. So let's subtract 28 from 37, which gives us a superheat of 9 degrees. So now let's look at an evaporator coil with a 6 psi pressure drop. Looking at the diagram on the right, you'll see the evaporator has an inlet pressure of 33 psi and an outlet pressure of 27 psi. So the closing pressure is going to be the 33 psi inlet pressure plus the 7 psi spring pressure equals 40 psi. Evaporator inlet pressure plus spring pressure. The bulb temperature equivalent to 40 psi is 43 degrees Fahrenheit. Saturated temperature equivalent to the evaporator outlet pressure is 28 degrees. So we subtract the 28 degrees from 43 degrees, which gives us a superheat of 15 degrees. Thermostatic expansion valves with an external equalizer. Applies closing force pressure from outside the valve using the pressure from the outlet side of the evaporator. Externally compensated. Using the diagram on the right, we'll see that we have an evaporator inlet pressure of 33 psi and an evaporator outlet pressure of 27 psi. So with the bulb pressure of 34 psi, and we convert that to temperature, equals 37 degrees Fahrenheit. The saturated temperature equivalent to the evaporator outlet pressure is 28 degrees Fahrenheit, which gives us a 9-degree superheat. By subtracting the temperature equivalent of the evaporator outlet pressure from the temperature equivalent of the sensing bulb. The model number breakdown for the TEVs. First position is the body type. Second position is the refrigerant. If there is an E in the third position, it signifies it is an externally equalized TEV. If there is no letter E, that indicates the valve is internally equalized. For example, GR-1-Z. The next position is the nominal capacity in tons. And the last position is the thermostatic charge. Let's take a look at TXV sizing. Can a 40-ton valve control a 50-ton system? Let's find out. Let's start by looking at pressure drop. At 50 psi, we will have some pressure drop. At 100 psi, we will have more pressure drop. And there will be even more pressure drop at 200 psi. Differential pressure drop. TXVs are designed with a 100 psi differential across the valve seat. So let's start with a head pressure of 265 psi. And then we'll subtract the suction pressure at the compressor of 75 psi. And then the liquid line pressure drop of 3 psi. The hot gas line pressure drop, 3 psi. Pressure drop through the coils, 20 psi. So the total pressure drop across the TXV is 164 psi. So by using this chart, looking across the top, I've highlighted 40-degree evaporator and a 0-degree evaporator. So at the nominal tons of the TXV, I've highlighted the line for 40 tons. If we look at a 40-degree evaporator, and we had calculated on the last slide, we had 164 psi pressure drop across the valve. So we're going to have to extrapolate a bit, but somewhere between 150 and 175, we can operate 49.4 to 53.3 tons of system. So yes, there are times when you could control a 50-ton system with a 40-ton TEV. In reference to sensing bulb locations, on a suction line smaller than 7/8 inch, the sensing bulb should mount on the top of the line. With line sets larger than 7/8 inch, it would mount on the lower half of the side of the line. For liquid stratification on larger line sets, the sensor should be mounted above the oil, but below the stratified liquid. That's the most active vapor refrigerant. Sensing bulb position. When mounting the sensing bulb on a suction line, make sure it's mounted on a horizontal section of suction line. Make sure that the process stub, the short piece of copper tubing sticking out of the bulb, is how they charged the sensing bulb with refrigerant when the valve was manufactured. Make sure the sensing bulb is mounted in a way that the process tube is always below the long tube that goes to the valve. Never install the bulb so the process tube is even with or above the pressure tube to keep the pressure line from being exposed to liquid refrigerant in the bottom of the sensing bulb. Also, the sensing bulb should not be attached to a vertical section of the suction line. Hunting or cycling. The TEV will modulate. The valve is in control, cycling, if the suction line temperature swing is less than 8 degrees Fahrenheit. The valve is out of control, hunting, if the suction line temperature swing is more than 8 degrees Fahrenheit. Electronic expansion valve, EEV. These metering devices are used in newer VRV, variable refrigerant volume, and VRF, variable refrigerant flow, systems. These are used in air conditioner and heat pump systems that have inverter duty compressors that modulate. Also used in larger systems with unloading compressors that are not inverter driven. This allows for precision metering, and you can replace the power head without recovering the refrigerant. They also will meter in both directions. EEV function. These valves respond as often as every 20 seconds to sensor input for open or close, allowing refrigerant volume to vary according to the load requirement. The valve assemblies use stepper motors that open and close a needle stem. One of the great benefits of this type of valve is the simple replacement of the motor head in the event of a failure. The needle and seat are isolated from the motor with a seal, and the system will not leak when replacing the motor head on some systems. Thank you for joining us for Essential HVAC Principles TF3 Refrigerant Metering Devices. If you have any questions or need more information, please contact the Cafferty Group Technical Service Advisors at one of these 12 locations.